In this video, we are going to talk about conjugate acid and bases. So, conjugate acids and bases. Now, a conjugate acid is formed by the base accepting a proton. All right, so what that means is it comes from the base because the base is the thing that is accepting the proton. Now, the conjugate base is formed by the acid donating a proton. So that means it comes from the acid. Now, something that I want to point out to you is that we're using the words formed. So that means these are going to be products. All right, those are going to be products. So our conjugate acids and bases are always products. So let's look at an example, and we can look at nitric acid in water. So when we look at nitric acid, when it dissociates in water, I'm going to first write nitric acid, which is HNO3, and water. Now, nitric acid is my acid, and it's going to donate a proton, whereas when water is in an acidic environment, it is going to behave as a base. So it's going to take on that proton. So when water accepts that proton, it becomes hydronium ion. And when nitric acid loses that proton, it becomes nitrate. So now we need to identify the conjugate acid and the conjugate base. Now, just by looking at this, nitrate does not have a proton, so it cannot be an acid. So that means it has to be a conjugate base. And if you notice, it comes from our acid and it turns into nitrate. And so that is the definition of our conjugate base. So nitrate is going to be the conjugate base. And since that is the conjugate base, hydronium ion has to be the conjugate acid. And if we look at that, our conjugate acid is formed by the base accepting a proton. Water is my base. It accepted a proton to form our conjugate acid. Now, when you are doing these, you can also form conjugate acid-base pairs. So your conjugate acid-base pairs are going to look alike. And when I say that, I mean, in this example, one thing has nitrogen in my reactants right here. I'm going to find the other thing that has nitrogen in my products, and that is my conjugate acid-base pair. When we look at it a little bit more closely, you can see that the conjugate acid-base pair is your acid and conjugate base or your base and conjugate acid. So these are our conjugate acid-base pairs. Now, when you are doing these different types of problems, If hydronium is formed, it is always a conjugate acid. So hydronium ion is always a conjugate acid. All right, let's look at a couple more examples. So we can look at phosphoric acid in water and dimethylamine, which is CH3, 2, and H. So go ahead and pause this video, and what I would like you to do is come up with the dissociation reaction, identify the acid, base, and conjugate base. All right, let's go over these together. So the first thing I'm going to do is write out my equation. So we have phosphoric acid plus water. I know that phosphoric acid is a weak acid, so it's going to exist in equilibrium. And since it is an acid, it's going to donate a proton. So we're going to get hydronium ion plus dihydrogen phosphate. Now, the phosphoric acid is my acid, which means water has to be my base. And I find hydronium ion, so I know that has to be my conjugate acid. Therefore, dihydrogen phosphate has to be my conjugate base. Now, in this one, it is a little bit trickier because both of my products have an ionizable proton. If that's the case, you have to look at where they're coming from, or you can just identify that hydronium ion is always the conjugate acid. So then the dihydrogen phosphate has to be my conjugate base. And I can look at my conjugate acid base pairs. Water is going to go with hydronium ion. Phosphoric acid is going to go with dihydrogen phosphate. When we look at dimethylamine, I'm going to go through the exact same process where we have our dimethylamine. And something I want to point out about this is here we have a nitrogen that has three things bonded to it. It is very similar to ammonia. So these molecules will act as a base. This proton right here is not ionizable. If you had another proton on there, then it would be ionizable, but we don't, so it's not. So in water, now water is going to give its proton to the nitrogen. So when that happens, we'll have CH3, 2, NH2. And now that is going to have a plus sign on it, and then we will get hydroxide. So my dimethylamine is acting as my base, and in a basic environment, water is going to behave as an acid. Now, the conjugate acid comes from the base, so that means my first product is going to be my conjugate acid, and that makes hydroxide my conjugate base. If you do a reaction and hydroxide is the product, it is always the conjugate base. Similar to hydronium is always the conjugate acid, hydroxide is always the conjugate base. Now, water is going to go with hydroxide, and my two nitrogen containing compounds are going to be my conjugate acid base pairs. Let's look at one more example. So we can look at hydrosulfuric acid and ammonia. So just like before, the first thing I want to do is write it out. So I have H2S for my hydrosulfuric acid and NH3 for my ammonia. Now I know that hydrosulfuric acid is my acid and ammonia is going to be my base. So when this happens, ammonia is going to accept a proton and it will become NH4 plus, and then hydrosulfuric acid will lose a proton, so it becomes HF minus. So here, the ammonium is going to be my conjugate acid, and my HF minus is going to be my conjugate base. Now, when we look at our conjugate acid base pairs, we can make a comparison between the strength of them. Now, if you were to look at Ka and Kb values, you can compare the different values. Now, if you have a weak acid, it is going to give way to a stronger conjugate base. If you have a weak base, you are going to get a stronger conjugate acid. Now, when we talk about something being strong or weak, in this case, we're not talking about a weak acid is going to yield a strong base, a strong conjugate base. It just means it's going to be stronger. And so you can see, look at your Ka and Kb values, and when you do that, you will see that hydrosulfuric acid is a stronger acid. Ammonia is a stronger base. Ammonium is a weaker acid. And HS minus is a weaker base. So your reaction always favors stronger to weaker. So in this case, the reaction favors the products because it's going from stronger acids and bases to weaker acids and bases.